All right, everybody. How we doing out there today? It's your boy Joe coming back for the end of part one and part two to our study exam here. Hope everybody's doing real good tonight. I know I'm doing good. Oh, where'd it go? Oh, 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 where'd it go? Get back on my face. Go. Oh. There I am. Hey, I'm back, everybody. Don't mess with me, you crazy thing. Alright, guys. We're gonna get at it tonight. We're gonna do an entire review from chapter 1 all the way to chapter 7. We made it this far. I think we can go all the way. Oh boy, all I hear is police cars and fire trucks going by tonight. Excuse me. Alright, enough of that. Woo! I'm back. Alright, everybody. How we doing tonight? Glad to be here. Hope you're glad to be here. Thank you again for joining me. Get your learning caps on. Get your coffee ready. Here we go. We got our coffee ready. Fill her up. That's good coffee, guys. Good coffee. All right. Like I was saying yesterday, guys. Just because I don't want us to jump into part 3 of the book already before we take a break for the weekend. I want us to do a complete review of what we've already gone over. Again, pretty high level stuff. So, my intentions today is we're gonna get over to the Pearson program, and we're gonna do a pretty length. We're gonna do from 1 to 7 of the test there. It should give us a good bit of questions. We're probably gonna see some questions that we've already answered, most likely. Doesn't seem like every time I've been cycling it, doesn't seem like it's been populating new answers. Whatever. At least we'll know if we know that the stuff by then. So we're gonna do that. We'll hit up on some of this, depending on what we feel, what we find that we are lacking on. We'll probably just do a quick review of that. We'll jump over to Packet Tracer tonight. The reason why we'll be using Packet Tracer probably most of the night is just because I want to just go over the SSH and the Telnet stuff again. And as you guys already saw, doing that stuff in Cisco Model Lab and GNS3 is a little bit difficult. So we're just going to be using Cisco Packet Tracer tonight. Easy peasy, lemon squeezy. Yeah. So I mean, this should be a good time to ask questions throughout the stream. So yeah, I'll open the floor to as many questions as possible as we go along, because we're not going to be directly getting into a particular chapter. All right, and then as we get towards the end of our time together, we'll do a brief overview of what we're going to be getting back into when we hit back on part 3 come Monday. All right. So yeah. So I guess where we'll start. Is we'll just quickly mention what we've gone over already. So chapter 1, if you remember, that was the introduction to TCP IP networking. Okay, that was chapter 1. Chapter 2 was fundamentals of Ethernet LANs. Chapter 3, that was the fundamentals of wide area networks and IP routing. Okay, and then we went into part 2. All right, and the first chapter in part 2 was chapter 4. Chapter 4 was using the command line interface. All right, and then we went into chapter 5, analyzing local area switching. And then we went to chapter 6, configuring basic switch management. And then chapter 7, that was configuring and verifying switch interface. So that was last night. So chapter 7, if you remember, that was duplex and speed. Okay. duplex and speed, and how to go between those interfaces on the command line. Okay. Chapter 6, that's when we configured telnet and SSH, and then we went through some passwords and username key pairs and whatnot. And then everything else was pretty much an introductory to pretty much networking, pretty high level stuff. Not too nitty gritty yet. So that's where I want to stop. At least till Monday, just to give ourselves a little bit of time to recuperate and whatnot, and that way we don't just jump into a whole new part and then possibly forget about it over the weekend. I wouldn't want to do that. All right. So that's kind of my thinking behind it. But part 3 though, part 3 is going to be pretty neat. We got some stuff to go through. We'll definitely have some more labbing and stuff like that, more hands-on labbing to do and whatnot. And then yeah, it continues on to there, part 4. So the first book itself covers part 4, part 5, part 6, part 7, part 8. Yeah, it gets even deep. It ends at part 8, I believe so. Yeah, part 8. Yeah, so coming. Copy it up. Yeah, today was a great day though today, guys. Yeah, I had some fun today. I also dropped I edited and dropped a new video up on my YouTube page. If you guys have time, check out my YouTube page. Tell me how it's looking. I've been putting a lot of work on Twitch. I've been putting a lot of work on just the actual how the pages look, and whatnot. Like I think I mentioned this. I still want to add, like, I got Nightbot in the chat too, but I want to add some more stuff to that so you guys can have some interactions with the Nightbot in the chat as well. But yeah, like I was just saying, I'm putting some time into how the actual Twitch page and the YouTube page. Most of the most I've been putting a lot of work into how the YouTube page looks and whatnot, setting that up. That's pretty fun to set up to make it look nice and what. But that's neither here or there, guys. We're here to study. Joe, we're here to study. We're here to learn. I know that. So let's get to the learning. All right. Let me switch over to my other camera. Right. Let's get started, folks. Let's get this party started. Ooh, you know what I gotta do? I'm gonna kill this music. And if I kill the music, I can bring this up. 16 decibels. All right. That's up. Volume real quick. Okay. All right. Let's launch the Pearson test stuff real fast. Cheer. We'll start off with our clean board as we always do. Clean the board. All right, let's get started. All right, so yeah, so we're gonna go with as many questions as possible. But our objectives though today is the first 7. Okay, we got 1, 2, 3, 5, 6, 7. Ooh, 7. This should give us a pretty sizely. This should give us a pretty sizely amount of questions to go through. That should take us some time. take us some time to hammer out and hammer through. Dribbling again. Dribbling coffee everywhere. I'm a dribbler. Alright. Alrighty, everybody. Let's get ready to do this. Alright. Joey Goofy tonight, right? Alright. Ooh, we got 54. So we're gonna have some fun stuff to do. Alright. The term segment refers to which layer PDU. Oh, I gotta get my markers ready. So segment again. Remember, guys? There we go. So we got our OSI. Well, I gotta stop calling it OSI. I really gotta stop. It's our TCP/IP model. All right. So we have our TCP/IP model. Okay. It's got 5 layers. Okay. 1, 2, 3, 4, 5. We have our data layer. So frame data. This is frame or MAC. All right. This is network IP. All right. This is transport. All right. Segment. All right. And then this up here is application, session. All right. All right. So the term segment refers to which layer PDU. So that would be the transport. All right. The user has sent a request to the server. What process does the server go through to determine which service has been requested by the user? So, I think this was one that we got hung up on. And it's segmentation. It's segmentation, right? That's what it goes through. So, a user has sent a request to the server. What process does the server go through to determine what service is being requested by the user? So that's segmentation. Segmentation, I believe. Let's find out if we're right. Oh, it's encapsulation. Dang. I knew we got this wrong last time. I should have. See, I'm not thinking about that. All right. Let's read the explanation. Okay. As data is sent from the sender to the receiver, the sender encapsulates the data into a segment, okay, which are encapsulated into packets, then frames, and then sent on the wire. The receiver de-encapsulates the PDU in the reverse order to determine what actual data that's being transmitted. Segmentation at layer 4 is used to chop up large data chunks of blocks into smaller pods of transmission. Fragmentation at layer 3, all right, is used to take a packet that may otherwise be too large to be supported on a given network and chop that packet into smaller for transmission. All right. So at layer 4, it chops the segment up. So it takes the frame and it chops it up. All right, segmentation. All right, so this is de-encapsulates. All right, breaks it up, sends it down to layer 3. Layer 3 fragments it. Fragmentation. Okay, that's kind of, at least that's from the explanation how it's explaining itself right there. All right, so let's keep it moving. All right. Which of the following terms represents layer 3 PDU in the OSI model? Which includes the network layer header and encapsulated data. So layer 3. So 1, 2, 3. So that'd be packet. All right. All right. The output is from the network analyst tool like Wireshark or something like that. Yep. All right. Based on the packet capture shown, which of the following is true? B is related to the formatting data into frames appropriate for transmission on some other media. What's B? B. No, B is that's IP. That's network. All right. Line A is used for logical addressing, routing, and path determination. No, that's MAC. That's layer 2. All right. C is information. The line C information is used to route packets through an internetwork. Let's look at C. That's the transmission protocol. All right. Line C corresponds to the transmission to the transport layer. That is correct. All right. Transmission protocol, TCP, transmission. Okay. All right. Let's just read line D for completeness. All right. Line D is used for connection establishment and transmit termination, flow control, and segmentations of block of data into some transmission. So that's line D is just telnet. It's nothing to do with that. So let's see. All right. IP functions at what layer of the OSI model? All right. Network, IP. Okay. Layer 3. All right. In describing line A from the graphic with the OSI model perspective, which is the correct label to be used in combination with the PDU? So, okay. In describing line A, so line A, which is MAC, which is layer 2, in describing line A from the graphic with the OSI model perspective, which of the following correct labels is used in combination with that PDU? All right. So line A would be a frame, right? Yeah, that would be a frame. Yep. All right. Refer to the diagram. The new connection that is going between campus 1 and campus 2 router is required to provide at least 500 megabytes per second of bandwidth. The routers are located 300 meters apart away from each other. Which standard of Ethernet should be used in this situation? Okay. So we want to go, and again, these ones are super hard to remember. And I just remember as Z as being the 1000 base T. So as I always think about it is that when I see Z, all right, the 802.Z, I think 1000 base T. That's the only one I can remember. So this is the correct answer is 1000 base T. Okay. All right. The diagram refers to which type of fiber mode cabling. Now remember, I even drew this last night. I drew this last night because I think we kind of talked about it real quick. But there's two types of single mode and then there's multi-mode. Okay. All right. So you have your fiber optic cable, and when the core on a multi-mode is a little bit bigger, all right, and that bigger amount results in more reflection as that ray of light passes through that wire. And then on single mode, that core is super duper small, so it only allows for single mode. All right, so this would be an example of multi-mode. Okay, multi-mode. All right. So the circle field part of the Ethernet header lists a value of hex 0800, which in the case means that the IP header follows next, as shown on the line below the circled field. What is the name of the circled field? All right, so that would be the type. All right, that would be the type. All right, let's keep it moving. Well, pick up. All right. The diagram shows a simple internetwork in which a local area network connections uses fast Ethernet. Select the answers that list the correct cabling type. All right. So remember, again, when we touched on cabling, let's review cabling again real quick while we're here. All right, we got to think about crossover and single. Okay, so we have PC. All right, we have router. All right, PC, router, and then access points. Access points fall in this category too, so I'm just going to draw an access, AP access point. So access points. All right, and we have switches. All right, bridges. All right, hubs. All right. So pretty much these all have their own same logic, and these all have their own same logic. Okay. All right. When we are connecting a PC to a switch, okay, the PC can receive on one side, and then the switch will be able to transmit on that same. So it will use single, okay, single cable, okay. Now, if we were to connect a switch and a bridge, what happens is the same side that it's receiving on, it's going to be the same side. Well, the same size it's receiving on will be the same size it's receiving on that bridge. So you would have to make another connection, all right, with transporting. So this would be crossover cable, okay, because you need something that's only receiving on one end and transmitting on the next. Receiving on one end, transmitting on the next. So this would be crossover for connecting these devices together, and then this would be all right. And then when you're connecting a PC to a switch, that'd be single. All right. All right. So crossover cable between S1. Yep. So that one's right. And then a rollover cable, Ethernet crossover cable between the switch and the hub, and that one's right. All right. So we have two crossovers. Okay. All right. Yeah, the network in the figure uses Cat5 cabling with RJ. Yep. We got to select two right answers. All right. All right. So the cable from W1 to to R1 connects. Nope. Next one. The cable from S1 to S2 connects at pin 6, and the other end picks at pin 2. So yes, because that's crossover. So remember in crossover, pin 2 on a crossover cable connects to pin 6 on that other side. Okay. Yeah, because pin 1 would connect to pin 3. All right, on that crossover. All right. So let's keep going down here. So this one is correct as well, because that'd be straight through. And then yeah, that's it. So those are our two answers. So the cable from S2 and R1 connects to both 6 and 6. Okay. All right. The network in the figure uses Cat5 cable. Which of the following statements are true about which wires inside of the cables connect to the thing? So here we go. Same type of question. So the S1 and S2 connect on 1 and 1. Nope. S1 and S2 connect on 1 and 3. Yep. Because that's crossover. All right. So S2 and S1 both can. Nope. S2 and R1 connect on 2 and 2. Yep. And then PC1 to SW1. Nope. And then the very last one, PC1 and SW1 both connect on 1. All right. All right. We've gotten, so this is actually I feel very, very good about how we've done this whole entire review, because if you guys remember when we first started talking about cabling, cabling was a rough spot for me. It was a touch and go type of area where I didn't have that knowledge really nailed down too tight, and when I was getting asked those questions, I was either guessing or I just didn't know, okay? But through us going over and over and over and over like we have been, Now I've been able to nail that into my head, and now I can clearly tell you, you know, how this logic works, why it works, and why it is the way it is. Okay. All right. Next question. Which fields are in the IPv4 header? Okay. Which fields? We have 3. All right. So we have time to live, yes, and protocol. Believe. Don't like that I'm guessing on this one, but I'm right. All right. A device uses MAC address 0 echo echo. Which part of the MAC address indicates the originating network equipment vendor? All right, so that'd be the first half of that MAC address. The first half of that MAC address. Okay, so if we were to just take this, take my little handy marker here, and we want the first, half. So here is the first half right here. Why is it maybe not working tonight? Oh, won't let me mark on that. Okay, that's cool. All right, so it'd be the first half. So it'd be that one right there. Nope, that one. Woo! That was weird. My marker didn't work for this some reason. Whatever, that's fine. That marker should mark on everything. It's cool. All right. From the output of R1, which of the following is accurate? All right. So the address, the MAC address 0 something 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 is designed to be assigned to a single network interface, never to be duplicated. That's correct. Yeah. Okay. All right. How many do I have? How many do we have there? Only one. Okay. The hardware. Cool. R1 learned the IP address of 100 in less than 1 minute. I don't think so. The probably faster than that. R1 will use address layer 3. No. All right. So it's 1. All right. In the figure. So here's another cabling question. Which of the following statements is true about the cabling? Okay. So the cable from S1 and S2 connects from 3 to 6. 3 to 6 on crossover. No, straight through. What's crossover? No, I don't feel that one's right. And PC, we only have, what do we only have? Select one. Nope. Second one's wrong. This one right here is right. Yeah, so it's this one right here. Boom, baby. All right. And a lease line provides a, remember I got this wrong. So a lease line, remember guys, if you know, we don't want to overthink. Sometimes we don't want to overthink these questions. So, you know, these questions are meant to provoke a response. Nonetheless, we don't want to overthink what these questions are asking us. So it's asking us, a lease line provides what kind of a service? What kind of a service does a lease line provide? It provides a physical line, all right? A physical telecom, whatever, you know, a telecom line, whatever you want to call it. This is a physical line from one, all right, server provider to another server provider, or to you, your building, whatever. It's an actual physical line. So what's a physical line? A physical line is a layer 1. That's a layer 1, all right? That's the data. That's the hard stuff. That's the Ethernet, all right? The Ethernet cabling, all right? That's what this question is asking us, okay? All right, let's do number 1. Keep it moving. All right. Based on the diagram, host A sends a packet to server B. The two serial links use the HDLC, while the rest are Ethernet. How many times does the packet experience re-encapsulation by a router? Now remember, every time a packet goes through a router, it is de-encapsulated and then re-encapsulated. De-encapsulated, re-encapsulated. It's continuing to remove, de-encapsulate those frames and then re-encapsulate them, okay? That's what that router is doing, okay? So if we were to count how many hops this thing takes just to get to server B, we start counting from the other side of the router, okay? So 1, 2, 3, 4, and then 5. Okay, so it is encapsulated, and it is de-encapsulated and encapsulated 5 times. Okay. All right. In the figure, all devices are statically configured with IP address, mask, and default gateway information. Assuming that all switches in PCs just completed a reload, the switch MAC address tables are empty. All right. The PC's ARP tables are empty, and none of the PCs or routers have sent a frame. Which of the following is true? So let's think. Everything is bone dry. Nothing has any tables full. Nothing. So we have to remember that once things start turning on, they start sending those ARP messages through that wire. All right, they start sending those ARP messages through the wire. This is one thing that caught me last time. So let's make sure we're reading these. So we have to select 2. So let's make sure we're reading them. All right. When PC1 pings PC2, the first Ethernet frame will be will have the broadcast destination. Yes, it will. Okay. All right. When PC1 pings PC2, the first frame will be an ARP request. When PC1 pings PC2, the first Ethernet frame will have 50. No, it won't, because it ain't gonna go to that MAC. It ain't gonna go to that router. Well, it will, but it's not intended for that router. All right. When PC1 pings PC2, the first packet will be an ICP. No, because remember when we said it's gonna be sending out ARP request. All right, first. All right. When PC1 pings PC2, the first frame will have PC2's MAC address as the destination. When PC1 pings PC2, the first frame will have PC2's MAC address as the destination address. It will. All right. First, when PC1, the frame that will be sent. See, this is what got me last time. I know that, yes, it's going to have PC2's MAC address on it when it pings it, okay? It is, we'll have a broadcast destination address. See, this is difficult because when it sends it as an ARP, it is going to be a broadcast. I know it's not none of these two. You know, because this way I got hung up. Because it's not, it's already going to send an ARP request out. All right, it's going to be a broadcast. I already know that. Yep, that's it. So yeah, so when PC1 pings PC2, gotta overthink that ARP, it's going to be sending that ARP first. And that ARP is going to have, it's going to be the FFF address, okay? So that's where, again, I had to revert back to not getting too far ahead in how the network's working. I had to take that step back and remember that these network devices are going to be sending out that ARP message, okay? That ARP message is going to be a broadcast address. So it's going to be just spamming out to all the devices that it can reach, besides it's where it generated from, okay? And it's going to be sending it out to the FFF address, which is a broadcast address, okay? So remember that. All right. A user at host 10.3.0.1 powers on a device and issues the ping at 10.3.0.2 command. What is true about the ARP request sent by the host 3.0.1? So, user powers on the device, issues the ping. What is true about the ARP request? The frame will be de-encapsulated only by the device using, this part of DNS. Host 1003 is attempting to learn layer 2 addressing. The device processing the request will reply with the unicast frame from 10.3.0. Yes. Okay. So that is right, and that is right. So the host is attempting to learn layer 2. All right. All right. Keep it moving. All right. Which answer lists an Ethernet based wide area network service? So which answer lists an Ethernet wide area network service? Okay. So we have Ethernet over MPLS. Okay. And we have Ethernet line service. Okay. All right. How does the receiver or HDL frame know what has been encapsulated within the frame? All right. How does the receiver of a HDL frame know what has been encapsulated in the frame? All right. From that, no, HDL3, no. The type header, the type field in the header. That's how it knows. Okay. The type field in the header. All right. Which of the following data link layer protocols are used to encapsulate data on a leased line? We have to select 2. So that's PPP. All right. Point to point and HDLC. All right. Which protocol finds an unknown layer 2 address from a known IP address? Okay. So we know the IP address. Okay. But we want to know layer 2 information. So those requests that are going through our network, those ARP requests are trying to find out layer 2 information. It already knows, it understands layer 3 information, the IP addressing, but it wants to know layer 2. So that'd be ARP. All right. If an engineer issues the copy running config startup config command, which Cisco memory type would the configuration be copied to? So remember, when you're actively engaging in configuring your device, although that whole configuration file that is being saved to RAM, okay? But it's not being that. If you were to just power off the device and then power back on, you would find that all that configuration that you just spent whatever amount of time on is now gone. So what piece of the actual switch is being, where is that piece, where is that configuration, where does it need to be saved? All right, that is in the NVRAM. So the non-volatile RAM, the non-volatile RAM, the NVRAM, that's what gives the starts the operating system up, and then it again uses the text file, all right, that you saved from RAM. It uses that text file as the configuration. Okay, all right. When the Cisco iOS command line interface is initially accessed via console telnet SSH with no extra privileges, what mode does it place you in? So that is in user mode. User mode. Okay. All right. Refer to the diagram. Which of the following connection parameters are used when connecting to the console of a Cisco switch? So remember, 9600 8 to 1, 9600 8 and 1, 9600 8 and 1. All right. If an engineer has completed a series of changes to a Cisco switch and wants to ensure that the changes are saved and retained across reboots, which command should be used? So what is that command again? Copy running config starter config. Copy running config starter config. Okay. Copy running config starter config. There it is. Woo! We getting it, baby, tonight. All right. What is the name of the Cisco iOS command line exec command that allows a user to run more powerful commands? Okay. So what is the name of the Cisco iOS CLI exec mode that allows a user to run more powerful commands? So that would be enable mode. Enable mode. All right. All right. Using a cable to connect a Workbench PC to a console port of a switch, you notice that the switch is non-responsive. A co-worker mentioned that the same PC was used with that same switch earlier today. The system LED on the switch is green. Consider the scenario, what should the technician do? So we need to select 2 answers. So we have to make sure we're using a rollover cable. That's one. All right. Verify a straight through cable. No. Verify the correct physical connections have been made. Check to see if the cable is a Cat 5 or higher. So we just have to. So here's our 2 things. Make sure that the cable is a rollover cable. Okay. And then we have to verify if we've actually made the connection. Okay. All right. Your switch is an air conditioning locked wire closet on the first floor of the building. There is a card reader on the door that allows only authorized personnel. On Thursday, you use Telnet to connect to the switch and issue the following command: hostname SW1 and log out. All right. So what didn't he do? What didn't he do, chat? You know what he didn't do? He didn't run the copy, run and config, starter config. Copy, run and config, starter config. Where does that get saved to, guys? That gets saved to your NVRAM, right? All right. It's not the register. Excuse me. No. So here we go. Got to save it to NVRAM. Boom, baby. All right. All IP addresses are configured for the PCs and correctly connected into the network. The MAC address tables on the switch should look like this. Yada, yada, yada. Oh, so let's notice. There is not. So there's a VLAN 2 and a VLAN 3. So there's VLAN 2 and VLAN 3. It's only showing that on VLAN 3, though, there's only a connection out of the 504. So 504, that'd be PC4. So 503, which is connecting to PC3, there's no MAC address for PC3 in this table here. Let's continue on. PC4 has the layer 2 address of PC3 in its ARP table. PC4 sends a unicast ping request to PC3 as shown in the packet capture. The output from the analyst tool. Yep. All right. So what is the switch gonna do? It's stating that PC4 sent a unicast ping. All right, it sent a unicast message to PC3. But when that message hits the switch, though, what is the switch going to do? Okay, the switch is going to flood the frame to PC. No, because these are different VLANs. It's not going to do that. Switch will rely echo request and dingy. I'm not going to go there. The switch will filter the frame or not filter the frame, forward it. The switch will filter the frame and not forward it. No, it's going to do that. The switch will flood the frame to PC3. So it's going to flood it. So it's going to send it as like a, even though PC4 knows the MAC address of PC3, the switch doesn't know the MAC address of PC3. So it's going to flood those frames out of 503. It's not going to flood them out 504 because that's the generator. It's going to only flood it out of 503. Okay? All right? That's because, again, a switch works at layer 2. All right? It's working at layer 2. This is layer 2's logic. Okay? All right. In the figure, all devices are statically configured with IP address, mask, default gateway information. Assuming that all switches have learned the MAC addresses of all the devices in the figure, PC1 pings PC4, and PC1 receives reply confirming that the ping worked. Which of the following are true about the frame sent in the network and their encapsulation? All right. And considering the frame, consider the header of the frame and any encapsulation of the packet. So, what are we asking for? So PC1 pings PC4. So PC1 pings PC4. It's divided by a router, okay, because it's in a different subnet. PC1 is 10.1.1.1.1, and PC4 is 10.1.2.4. Sorry, the 2. So we're looking right here. So the 255, it's in the /24 address subnet mask notation. So it's identifying as 2 and 1 as being the actual network. Well, 10.1.2 and 10.1.1 as being the network, and then 1 and 4 are just the the host parts of that address. So we have a router. All right, it's all right. So what is going to happen? What's going to happen, Slappy? And now I see where I got this wrong. So all right. The frame that contains the ICMP echo sent by PC1 has the destination MAC address of 50 out of 501's interface. Let me just continue on. So we have to select two instances. Okay. The frame that contains the ICMP echo sent by the frame that was sent the ICMP reply sent by PC4 has the destination MAC address of PC1. No, it doesn't. So frame that contains the ICMP echo request sent by PC1 has the destination MAC address of the 501's interface. Let me hold on to that one. I'm going to hold on to that one just for now. I don't think that's right, but let's continue on. So the frame that contains the ICMP echo sent by PC1 has the destination address of 10.0.4. So the frame that contains the ICMP echo request sent by PC1 has the destination IP address of 10. I think that's kind of right. All right, but let's continue on. Just get rid of that one just for now. The frame that contains the ICMP echo request sent by PC1 has the destination IP address of 10.0.1. No. The frame that contains the ICMP echo reply sent by PC4 has the destination MAC address of the 50 reply is the 501's MAC interface. So it's that MAC's. It's saying that it's picked up that MAC's interface. Possibly now. Yeah. All right. Yes, that is right. The frame that contains the IPv6 request sent by PC1 has destination MAC address of PC4. No. So here we go. So again, this is where I got hung up last time. So when that message is coming through here on this wire, yeah, right? It's going to be sent out here. So this is though saying that it's on here, but it's not. So the frame that contains the ICP got reply sent to PC4 as destination MAC address of PC1. No, it doesn't. The frame that contains the ICP echo request sent by PC1 as destination MAC address. No. The frame that contains the ICP echo sent by PC1 as destination MAC address of PC4. No. So I believe we're right. Man, I had it right the first time. All right. Let me just take a look at this. So when it comes through here, it picks up that MAC address. That MAC address. All right, and then it gets sent out. See, I still thought it was picking up that MAC address as it reached out. All right, that's another I gotcha. That's another I gotcha, JoJo. All right, continue on. All right, after power on, a frame arrives at a switch. The switch had not yet learnt the source MAC address of that frame. Which actions must the switch take in case? After power on, the switch arrives at a frame arrives at the switch. The switch has not yet learnt the source MAC address of that frame. Which action must the switch take? Switch adds the source MAC address to its MAC activity. Yes, it does. All right, the switch adds the destination. No. The switch adds the source and destination. No. Switch checks the frames and loops. No, so it adds the source. All right. How does a switch build its MAC address table? By listening to outgoing frames and examine. Nope. By listening to outgoing frames and examine the source. That sounds good. By listening to incoming frames and examine the source. So incoming frames. Woo. Yep. All right. Let's keep moving. What is the default aging time for a MAC address table? It's 300 seconds. Boom. All right. All host switch ports reside in VLAN 1 with no port security or static MAC address tables. Entries defined. Host B remains powered off. but all other hosts can ping each other successfully. Later, host B powers on and the user issues the ping 10.1.1.4 command to generate host B's first network traffic, which of the following is true. So 10.1.1.4 is D. So B is pinging D. All right. Now remember, PCB, this is where I got hung up last night. PCB has been powered off. So it's going to be sending out an ARP request. And an ARP request uses a broadcast address, the FFF address. Okay? So, with that in mind, what are we going to do? Frame will be forwarded out. Switch 2's got 01 interface. Yes, it will, because it's going to be flooded. All right. Frame will be forwarded to host B. Yes, it will. The frame not. No, it's going to be flooded. It's going to be flooded to there too. All right, so it's those two right there. All right. Which type of memory does a switch use to build its MAC address table? So that would be the TCAM. All right. What will a switch compare its MAC address table to be able to forward a frame? It's not IP. It's not IP. It's not destination. It is source. Source MAC address. Whoa. Oh, I'm stupid. I'm stupid. That's what I am. What will a switch compare its MAC address table to be forwarded frame? Yeah, I'm dumb. Sorry, guys. I apologize for that one. That was a hiccup in mine. All right. In the figure, the 2960 switch has been taken out of the box and cabled. And PC2 can communicate through R1 with the rest of the IP network. However, no configurations have been made to either switch 1 or switch 2. As a result, the network engineer sitting at the management station on the right of R1 cannot ping or telnet S2. Which of the following configuration commands when entered in the correct order on SW2 allowed the network engineer to ping or telnet to the management? So it connects to the thing. The rest of the IP can be configured. However, there can no configuration been added to switch 1 or switch 2. As a result, the network engineer and the management station on the right of the router cannot ping or telnet. So it cannot ping or telnet. So we need to select 4. So we have interface VLAN. We want to move into that. We want to give it the IP gateway. Oh, wait. All right, that one. And unselect that one. Give it no shot. Then IP address. That one. Okay. All right. An engineer logs into a device and performs some troubleshooting. The engineer expects to need to repeat as many commands as so he wants to ensure the device remembers the commands and in the device history buffer for easy recall. Which commands can turn that off. All right. All right. An engineer, yeah, he wants to make sure that the history buffer is large enough to remember the commands that he's issuing, because he states that he's going to be reissuing multiple commands over and over and over and over the same commands over and over and over again. So from enable mode, it would be terminal history size, all right, and then from the global configuration mode, it is history size, okay. All right. A local user Bob has been created on a switch, and the following output A local user Bob has been created on a switch, and the following output is from the same switch. So crypto key, my RSA key. They have the domain name. Yep, RSA key. All right. Bob has an IP address on the computer and can ping the interface on the switch. SSH is enabled on the VTY lines, but Bob cannot log into the switch via SSH. All right. Why can't he do that? No, that's not it. They generated the RSA key. They figured that require local login authentication. Local login authentication. So they never went into the VTY lines and then pretty much enabled for local login. Okay. All right. The exhibit shows some configuration commands that sit in a text file. After adding this configuration to a switch, the user will attempt to connect with username Fred, password Hope. Which of the following best describes the accuracy of the configuration allowed users to attach to subnet 10.1.1.0-24 to use subnet on the host. Let's just look at the example. So we have host name, we have a domain, we have username. They created a crypto key, interface VLAN 1. They gave it an address. Let me see. No shot. Cool. Oh, local log. Oh, okay. So they don't have login local. So they didn't create. They didn't make the. They didn't enable for local login. Okay. They didn't enable that. They enabled Telnet and SSH. Cool. So the configuration needs local login. Yes. So it's this one right here. They did everything else correctly, but they didn't configure local login on the line VTY lines. All right. As an administrator, you decide to change the password periodically on the switch. You enter the following command: enable password blah blah. The next time you telnet to the switch, you have been prompted for the password, but Bubba is not accepted. Why isn't Bubba not accepted? All right. The enable secret password has been changed and said. We should have been in line configuration mode. Change the password periodically on the switch. The telnet protocol is not allowed. It doesn't state any of that. The enable password that was set on the VTY lines. Enable password on the VTY lines. Enable password, enable secret password should have been changed and said. We should have been in line configuration mode for setting and issuing this command. Which answer encrypts the password that will be required of the user so they can move and do exec command. So that, remember guys, so to encrypt, so you'll be in global configuration mode, all right, and you use the command enable secret to create that password that will be required to move from user mode to privilege mode, all right, enable mode, whatever you want to call it, all right. So that'd be the enable secret, and that encrypts that password, okay. All right. Which two of the following actions provide the best security for accessing a router's privilege mode remotely? So which two of the following actions provide the best security for accessing a router in router's privilege mode remotely? So enable SSH using the transport input SSH. No, because you're still going to be using SSH. Configure the enable password. Nope. Configure enable secret. Yeah, that is encrypted. Enable SSH and disable telnet using the transport input SSH. Yep. Okay. So we're going to enable SSH, and we're also going to do the enable secret password too as well. All right. Which command will generate an SSH encryption key? So remember, we went over this a couple of times. It is crypto key generate RSA. Crypto key generate RSA. Crypto key generate RSA. Okay. It's not crypto key SSH. Don't let that confuse it. It's crypto key RSA. All right. All right. Refer to the diagram assuming auto negotiation is enabled. What would be the result? Assuming auto negotiation is enabled, what would be the result speed in duplex of the links between the switch and host B? So switch, host B. So if it only had 10.100, so you're looking at 100 in full. All right. All right. Refer to the diagram in the exhibit. Which of the options is a potential reason for the interface status shown for the Ethernet interface shown in the figure? Let's take a look at the exhibit. So we have FOS01. It's been assigned to 10.10.10. It's up. It's manually. It's down. So status down. Same thing on this interface, all right? Oh, I mean, right away, but it doesn't. It's not giving me the. I'm gonna assume already they're not in the same subnets. So they're definitely not in the same subnets. That's one thing. Disconnect, mismatch interface speeds, different subnets. So it's different subnets. And oh, the different speed ports too. So the mismatch interface speeds. Yeah. Okay. So those should be our two answers right there. Oh. Let's talk about disconnected. Oh, okay. The interface may be down state for some reason. But you're illustrating a cable. Stupid question. Stupid question. Don't show the cable then. Just show the two routers. I'm gonna get mad at it right now. All right. Refer to the diagram. Both switches are Cisco switches. What would be the state speed in duplex of the link referred on switch 1? So switch 1, auto negotiate, fails because switch 2 does not use it. No longer is using auto negotiate. So switch 1 is configured at speed 100, speed 1000, and duplex full. What would it put these? And it should be up 1000 full. That's stating that it's auto negotiates fails because switch 1 doesn't use it. So it's this. Yeah, I knew it was that. Now they're trying to get tricky. That's fine. Let them get tricky. Try to confuse me. All right. refer to the diagram. If auto negotiate the speeds in duplex and in between host B and the switch works, what would be the resulting speed in duplex? If auto negotiate of the speed in duplex between host B and the switch works, what would be the resulting speed? So you have 100 and full. Yeah. Okay. All right. What are common local area network layer 1 problem indicators? So that's layer 1. All right, very low level. It's not IP. It's not incorrect VLANs. Could be late collisions. Could be high bandwidth utilization. Collisions, late collisions, and collisions. All right. All right. Refer to the diagram. If auto negotiate of the speed in duplex between host A and host A and the switch failed, what should be the resulting speed, assuming sense failure in duplex? So host A is 10. Yep, that's cool, and all the interfaces there. So if I negotiate of the speed in duplex between host A and the switch failed, what would be the resulting speed? It would be 1000 full. I'll negotiate on both the speed and duplex happen. The two rules that follow. The slowest support all is used in duplex will be half. Okay. I just learned something. Okay. Refer to the exhibit based on the information shown in the exhibit. What can be said of the configuration of the gigabit 0-4 interface? Let's check it out. So gigabit 0-4 shown connected, half duplex, and then it's been set at 100. So it's half and 100. All right. We need to select two answers. The interface duplex has been the speed command has been configured. That yep, and that. All right. Woo! We got through all 54 questions. Let's see how we did, guys. So I'm pretty pumped up to see how we did. I think we did pretty well. And we did. Look at that. We're getting it, guys. We're getting it. That should be a 1000, though, not a 907. You tricky Ricky questions, you. So I got one wrong on the first thing. I did. None. I got 2 wrong on chapter 5. All right, let's do this again then. Let's do chapter 1 and chapter 5 again. And chapter 7. So we have to do chapter 1, chapter 5, and chapter 7. Okay. Do it again. So we need chapter 1, chapter 5, chapter 7. All right, let's do another quiz. Come on, give me some different questions. All right. The term segment refers to which one? Transport. The user sent a request to the server. What does the server go through to determine what service should be requested? Deencapsulation. Which of the following terms represent a layer 3 PDU in the OSI model, which includes the network? So that'd be layer 3. Layer 3 is packet. IP functions at which level? A network. Yada. Cool. All right. What's the question? In describing line A from the graphic, which with an OSI model perspective, which of the following, which is the correct label to be used in combination with the PDU? So line A pointing towards that. Okay. So that would be frame. It's looking at layer 2, okay? It's looking at layer 2, which is frame. Yes. All right. Next question. Based on the package shown here, which of the following is true? All right. Line C corresponds to the transport layer. Yes, it does. Line C information. Nope, no routing. Line A refers to logical. Line A, no, that's MAC address. That's layer 2. Line B is formatting data into frames appropriate for transmission. No, line B is IP network. Line B is used connection in. No, that's just telnet. Okay, let's see. All right. Yes, it's bad that I know this one already, but I want to review it anyways. So PC4. You know what? I know this one already. It's gonna flood. It's gonna flood out the frames. All right. How does a switch build its MAC address table? It's by listening to incoming source. By listening to incoming source. By listening to incoming frames and examining the destination. No, by listening to incoming frames and examining the source. 300 seconds, not milliseconds. What will a switch compare its MAC address table to when forwarding frames? What will a switch compare its MAC table to be able to forward frame? Destination, Joe. Get it right. All right. Assuming all the switches have learned the MAC addressing in all devices in the figure, PC1 pings PC4 and PC1 receives the reply confirming that the ping word, which of the following is true about the frame sent through the network in their encapsulation. When considering a frame, consider the header of the frame and any encapsulation points. So I got caught up on this last time. The frame that contains the ICP echo request sent to PC1 as destination MAC address PC4. No. The frame that contains the ICP echo request sent to PC1 as the destination IP address of. So the frame that contains the ICP echo. No. The frame that contains the ICP echo is second frame of the one has the destination address of that. Yes, that's PC4. Yes. The frame that contains the ICP echo reply sent by PC4 as the destination MAC address of the 501's interface. No. The frame that sent the echo request sent by PC1 as the destination MAC address of R1. So yes, it has the R1's MAC address. Remember that, because it came into that NIC. So it's going to have that NIC. So yes, because this is the de-encapsulating interface. So since it de-encapsulated that, that's what it's going to pick up that MAC address. Okay, I can't understand that now. Okay, very good. All right. Which type of memory does the switch use to build its MAC address? TCAM. Next. After power on, a frame arrives at a switch. The switch has not yet learned the source MAC address of that frame. Which action must the switch take in this case? Hasn't learned that. So after power on, a frame arrives at the switch. The switch has not learned the source MAC address of that frame. Which does the switch do? So the switch adds the destination. Nope, the switch adds the source. Yes, it doesn't add anything else besides the source MAC address. Okay. All right. All hosts in the same port reside in VLAN 1. No port security. No static MAC addressing. Host B remains off, but all other hosts can ping each other successfully. Later, host B powers up and uses the MAC address 10.1.1.4 right here. Host D command generated by. So remember, it's going to be sending out an ARP request first. That's going to be a broadcast message, all right, that's going to get flooded out everywhere, all right, besides where it came from. All right, it's even going to it's going to go to A, it's going to go to C, D, E, F, and then it's going to go to switch 2, it's going to go to switch 3, okay? The frame would be flooded out. Yes, it will be. The frame will be flooded out. Yes, it will be. The frame will be forwarded to S2, but not S3. Nope, it's going to go to S3. And it's gonna go to it's gonna go to host A2. All right. Refer to the diagram, and also if auto negotiate of the speeds in duplex between host B and the switch port works, what would be the resulting speed for the duplex? So host B, all right, and the switch, and then auto negotiate is working. It's working. All right. So it's gonna go to 100 and full. Okay. Further the exhibit, based on the information, shows the exhibit. What can it be said of the configuration of the gigabit 0-4 interface? Gigabit 0-4. It's been set to half of 100. Half of 100. It's been physically sent to half of 100. Very good. All right, refer to the diagram. If auto negotiate of the speed and duplex between host A and the switch failed, so the switch has failed at this point. All right, what should be the resulting speed, assuming sense failure? Assuming sense failure. So it's going to revert back to the slowest speed in duplex. Slowest speed in duplex. Slowest because it failed. Auto negotiate failed. All right. What are common local area network layer 1 problems indicators? Collisions and late collisions. All right. It's not incorrect VLANs. Doesn't care. It's not layer 1 stuff. It's not high bandwidth usage. That's not layer 1 stuff. And it's not incorrect IP address. Layer 1 does not care about any of that. Layer 1 just cares about collisions. Layer 1 is physical. Physical. It's the wire. All right. It's the bits traveling through there. All right. Refer to the diagram. Both switches are Cisco switches. What would be the state and speed and duplex of the link referred to SW1? So if auto negotiate fails because S1 doesn't use it, it's no longer using that, so it's going to go to, still going to be at 1000 in full. Yep. Okay. All right. Refer to the diagram, assuming auto negotiate is enabled, what would be the resulting speed and duplex of the link between switch and host B? Switch and host B. So you have 100 and full. 100 and full. All right. Refer to the diagram in the exhibit. Which of the options is potentially the reason for the interface status shown in the Ethernet interface shown in the figure? So manual, down. The different speeds too. So mismatch interface speeds, and then disconnect the cable. Cool. We got 1000. We got 1000. All right, cool. All right, we did another successful review. I'm happy about that. I'm happy. All right. Cool. All right. I'm glad we reviewed it twice. Again, this is how the only way we're gonna. This is again how we're gonna hammer this down. This is how I'm gonna hammer it down too in my own head, is by continuing to review it. Like we're continuing to review it the way we are. All right. The only way this is going to become second nature, it's like anything else you can do in life, is through repetition. Repetition, over and over again, all right? Just excuse me for 1 second, guys. I'm going to go get just another drink real quick. My throat's getting dry. Hold on, everybody. All right. All right, I'm back. All right. See? We'll switch cameras. Alright. I said alright. There I am. I'm back, everybody. How we doing? Alright. So, we're gonna do some reviewing. Alright, let's get this back up. Got my little handy dandy Windows PC opened up. Ooh, burp. Got packet tracer up in it. Already fired up. All right. All right. Let's do some labbing over what we've done. Let's grab, and if you're with me, guys, I encourage you guys to follow along in packet tracer on what we're doing. Okay. Let's grab some switchies. What's the difference between you two? Not much. I use the same switches each one. Let's grab some switchies. Two switches should be good. Two switches should be good. Bridge here. And let's grab a router. Handy dandy router. A router. A router. A Buddha. Let's grab PCs. Couple PCs. Go. PC for you, and PC for you. Very good. Oh, very good now. What I will do in this demonstration, hook up a PC here, and that will be the PC that we do the console to, so we can go over to counseling. When I hook up to the USB, ooh, it's got two USBs, doesn't it? What? There it goes. We got that connection. And let's make some other connections. Straight through, proper crossover. All right, so let's do this the right way too, so you guys can follow along. So what I did first, so we used a console cable. So we're gonna log into this router via the PC. Okay, all right. So let's grab some connect. I'm not gonna use the auto connection tonight because I want us to use what we should be using. Okay, so remember when we're connecting a router to a switch, that's straight through. Okay. Connect here. We'll do the 5.0. We'll connect this one to its that's cool. That one. You guys can see the port interfaces. And then same thing, we connect here. We're gonna connect this one to bar 2 to here. Okay. Through 3 to here. You guys should be able to see this. Okay, hope. Yeah, that's good. And then what we'll do is, remember, now that we're gonna connect a switch to a switch, we gotta use crossover cables. Crossover cable. All right. We'll connect these over through gigabits to its other gigabits. All right. Now we're going to grab another straight through cable. I'm going to connect this PC to here. Okay. Spread that out a little bit so you can see the port interface. Okay. Go, and then remember we have to use, because remember bridges use the same logic like switches, so we could use a crossover cable. So use a crossover cable. I think those bridges only have fast. So I'm gonna connect it there. Okay. Then we're gonna use a straight through cable to connect from the PC to the bridge. All right. And then that makes our, so we've now just created our simple and easy peasy, lemon squeezy topology. All right. We're not going to get into VLANs and nothing like that tonight. Nothing crazy. Okay. This is just what we've been reviewing. So we just actually went through the cabling. So this is what we did. So instead of using the automatic cable to let us choose what we wanted to do, all right, we used we went about it the real way. So we hooked up a console cable. So with this PC right here is going to be used as the console. Okay. All right. So this would be the PC that we're sitting in we're in that office. Okay. And if you can imagine, I guess if you can imagine all of these network devices sitting in that same rack. All right. These PCs are out and about on different, in different, I guess in different cubicles or whatnot, that's where those are sitting. And this PC right here, this is the management PC that sits inside of that same office or same cubicle that this server rack is sitting in. All right, and the only reason why we grabbed the bridge is just to demonstrate what the switch's auto negotiate logic is going to do when it deals with a bridge. All right. Should I grab a hub too? Nah, we won't grab it. We won't grab a hub. So let's go over to the PC. Now remember, we don't have any IP addresses or nothing like that yet. We have to. What we're gonna do is we're gonna log into that. We're gonna log into that router, and we are going to create a DHCP server inside of that router. Now remember, so here's another part of what we've talked about already. Our terminal emulator that we're using, most likely you're probably gonna be using a program like PuTTY. All right, that's PUTTY. All right, you need to have these settings established. So the bit rate, bits per second, 9600, data bits 8, 0, none, and then start bit 1. All right, so 9600, 8 and 1, 9600, 8 and 1. All right, that's going to be your settings. All right, so here we are. Now we're actually in the router. So it's asking us if we would like to go through the initial setup. I'm going to say no. All right, we're in the router. So I'm in PC3, but via the console. Now we haven't set up any security and anything like that yet. So that's that logic. It by default in Cisco's operating systems, it states that if you can physically connect to that network device via the console, all right, by default there is no security set up in that. All right, but we cannot telnet into that. We can't SSH into that because SSH and telnet work via the network. So via the network, to move between an actual network, you need some kind of addressing. And the addressing that this network is going to use is going to be using IPv4. All right, Internet Protocol version 4 as its addressing. Okay. We're not going to be going into version 6, not till later. Okay, but right now we're using IPv4 as our addressing. Okay. All right. So we're here. We're in our router. All right. Now I'm gonna do a very, very simple setup. Okay. All right. So we're gonna do very simple Sam, because I'm a simple man. And we'll write some of our configurations here. What do we got? All right, so why isn't my pen working tonight? All right, let me close you out. Start you up again. Sorry, just give me 1 second. I'm trying to get my Epic. I love Epic pen. Use it all the time. I don't understand why it was breaking on me. There it goes. Now it's working. All right. So we'll set up. I guess when we do set up a username and password, we're going to use very simple username and password combinations here. So let me just make that a little bit smaller. So we'll say the username. So the username would be Cisco, and then the password. Password will be Cisco as well. All right, so we're going to use Cisco as our password. Same thing for our enable secret password. Well, you're going to use Cisco as well. The reason why I'm writing this down so I don't forget as we're going along. Even though it's super simple, I have a tendency to forget. So we're going to use this as our just super simple passwords. Okay. All right, that way we don't forget anything. And then we'll put our addressing and everything else over here. And here, we'll establish, we're going to go ahead, we'll establish our addressing to our edit. So the router, so R1. So R1 will have an IP address of 10.0.0. I'll do the 1968 for you guys tonight. 1968. 192.192.168, so this way it can be more like how you guys' houses are. .0.1, and we're going to use the slash 24, the subnet slash notation. Yeah, the slash notation subnet as 24. Okay, keep it simple, and that is 25.25.25.0. Okay, very simple. All right, and then we're going to set up DHCP. All right. And the network obviously is going to be 192.168.0.0. All right, so that's going to be the network. All right, and be 25.25.25.0. Hold on 1 second, guys. Our monkeys are getting crazy again on me. They're wrestling in the other room. Walls again. I had to tell my monkeys to stop bouncing. They're gonna come right through the walls here in a second on me. My crazy monkeys. All right, so we're gonna set up DHCP. That'll be the DHCP network. And then from there, all right, DHCP is going to establish all of the IP addresses. So we won't write down all the IP addresses right now. We'll let, once we configure DHCP, we'll write down our addressing from there. So, all right, so here's going to be some of our just username, password, key combinations. This will be an enable secret password, and then this right here will be our initial router, and then this will be our DHCP network. Okay. All right. So we're back on our router again. So from there, we have to move into enable mode. Okay. So enable. There's the first command. All right, so there's that little hashtag. You guys can see this pretty well. Okay. All right, so from there, we're going to move into configuration, terminal mode. All right, and let's we'll set up. What we'll do is we'll set up we'll set up SSH and all that as we're still in this mode, and then when we move, when we move into setting up the DHCP server and all that stuff too. So okay, so from here now we're going to give it the host name. All right, the host name command, we're going to call this R1. Okay, now we're going to say IP domain name. Okay, and we're going to give this the domain of, we're going to just say lab.com. Very simple. Okay, so that's going to be our domain name. All right, and then we're going to say crypto. All right, key generate. So generate, and then RSA. Okay, crypto key generate RSA. All right, that's going to be the command that's going to generate that. It's going to generate that SSH key for us. So don't get tripped up because it's saying RSA. All right, but this is going to generate that SSH key for us. Okay, we're going to tell it for, this is what you can set this as whatever you want to, but we're just going to send it for very simple purposes. 1024. All right, 1024. Very good. Now we want to ensure that the router SSH is using the proper version we want it to use. So we're going to give it the IP SSH version command, and then we're going to say we want to be using version 2. So as you saw what just popped up on the screen, SSH 1.99 has been enabled. We want 2. Cool. All right. Now we're going to move into the line BTY 0 through 15. Okay, we're going to move into the line BTY 0 to 15. Press enter. Okay, now we're going to say we got a couple things we want to say in here. We're going to say login local. Now we haven't established the Cisco the username keyword pair yet. We will after that. So we're going to say login local. Okay, the reason why we're saying login local, what that's going to tell it is going to use this combination. Okay, all right, we're going to say login local. All right, and we're going to say transport import SSH. Okay, so we're going to say transport import SSH. So that'll enable anybody trying to get into our router via telnet. Okay, all right, so it just makes it more secure. Okay, all right, we'll exit. All right, now we're going to hit it with the enable secret. Again, if I can spell it tonight, enable secret, and we're going to give it the enable secret command, and we're going to give it the enable secret password of Cisco. Now remember, the enable password or the enable secret, that's going to get from the user mode to enable mode. All right, so but the enable secret, that's going to encrypt that password. Okay, because if you just use the enable password command with your password key phrase, that's still going to show up as clear text on your when you run the actual show, the show running or the show command. All right, so to give us an extra layer of security, we're going to enable secret. Okay, we'll establish that. Now we're going to establish the username Cisco. All right, and then we're going to establish the password as now we can do, I guess we can do the enable. All right, just to keep, I guess, things simple for now, let's just do it like that, and then we'll just do secret. We'll do Cisco. Okay, so we've established SSH from there. All right, so that creates our SSH. Now we got to now move into our interface now, and our interface that we're going to be using is going to be the 500 interface. So we're going to move now into fast. Interface fast Ethernet 0-0, because that's going to be the interface that's connecting to our network. Okay, we're going to give it the IP address. It's right here at 192.168.0.1 at the 255.255.255.0 subnet mask. Okay, very good. We're going to hit it with a no shut. All right. We'll give it a description. All right. We're going to give this description to say inner network. Inner network. Okay. Very good. All right. Exit. Now let's create our DHCP server. So we're going to say IP DHCP pool. All right. And we're going to give it the name of inner net. All right. That's gonna be the name of our DHCP pool. All right. Let me say network. All right. Now we're going to establish the network that we want this DHCP server to start allocating address within that range. So we're going to give it that range that we want. So we want the 192.168.0.0 networks, because that's what we just gave our router. That router's interface is the 192.168.0.1. All right. But that, what we're saying is the 192.168.0, that's the network. 1 is the host. Okay. 192.168.0. So right here from 192.168 to 0, this is the network. 1 is the host bit because we've established 255, 255, 255, 0. Okay. So from this bit all the way back is network bits, and from this bit all the way to 254 is host bits. Okay. All right. So what we're telling DHCP is from 192.168.0, again, this is our network. He can start allocating addresses out from there. All right. Now it is a best practice, and we'll say this. We'll go into it. Once we configure this, we'll configure we'll exclude some addresses from there just as a best practice. That so we're not handing out addresses that, maybe we don't want to hand out all those addresses. Maybe we want to save some of those addresses for network devices later on. So we'll show you that little configuration too. So let's get back to the establishing DHCP. All right. So 255, 255.0. All right. And we're going to give it the default router. Very important now. 192.168.0.1. That's our interface on that router. Now that's going to be our default gateway. Okay. Now we can set up DNS too. All right, we'll say 192.168.0.1. Not 0.0. So we'll give that as the DNS server for now. We haven't got into all that yet, but when we get a little bit further, when we establish actual rail connections on Cisco Modeling Lab. All right. Again, the only reason why I'm going through Packet Tracer right now and using Packet Tracer right now, because it's going to allow me to give you guys a better example of what we're going to be doing, just because of the problems I found with the images on Cisco Modeling Lab. Okay, but we're going to get back into Cisco Modeling Lab because it's going to be very important for us to use actual rail images and connect to the rail internet as we progress through our studies here. Okay. But that does not take anything away from Cisco Packet Tracer. I'm using Cisco Packet Tracer right here, right now, guys. It's a great program, all right, and it's free. Download it, okay? All right, so that's that. All right, so I'm not going to get into any other complicated configurations from there. That's all I'm going to establish, okay? Now let's do IP, DHCP. All right, we're going to hit it with the exclude. Now this is when you can establish that range of addresses that you want to exclude from the DHCP server allocating out. So we're going to say from 192.168.0.0 to 192.168.0. We're going to say don't give out any of those addresses. Okay, so now it's going to start at 192.168.0.101. Okay, that's where it's going to start now. Okay, so we've established SSH. Now we have to verify that we've done all this. Okay, but what is the most important command right now, guys? We've done, I think we've done probably, 10, 15 lines of configurations. If we were to just log out of this router right now and this router was to shut down, what would happen? What would happen is everything we just did would not be safe, because everything that we've just done right now that is in that router's RAM. It hasn't been saved to its non-volatile RAM, to its NV RAM. All right. Again, the non-volatile RAM, that is where this configuration file needs to be saved to. So when it reboots, it's going to use this as its configuration file. Right now, and we'll do it. I'll do a show run, and then I'll do a show start so you can see. So we've established SSH, DHCP, we got that done. So I think I'm done. So let's exit. All right. Now let's do a show running configuration. Let's check out what we got. All right. So let me grab my handy bandy, little marky. What do we got here? We got host name, we got our enable secret, we got our DHCP, we got our little pool going on. That's our network, that's our default, that's our DNS. Cool. All right. Got all that established. Oh, I just erased all that. No big deal. Actually, I can go back. Yep. Fix that real quick. That way I can keep that. Okay. And yep. And there's our username. All right. It's showing IP SSH version 2, what we want. Showing our IP domain name at lab.com. All right. There's our first interface fast Ethernet 0-0 description. Remember, we gave it a description. That's our inner network. There's our IP address we just gave it, 192.168.0.1 at the 24/ notation network. Okay, cool. Yep. So we've told it that on the VTY lines we want just SSH. We don't want telnet. Okay, and there's login local too. That's another big one right there, guys. We've established login local, so it's going to use this user and password key combination. And again, transport SSH. So we've told it it's going to use just SSH, not telnet. Okay. All right. So that's the running configuration. Let's take a look at our startup configuration now. Ooh, startup configuration is not present. So there's actually no start configuration present on this device. So it's not even going to show us. That's a bummer because I wanted you guys to see it, an empty one. All right. So again, what is the most important command that we need to do? What's up, Fuzzy Moogle? Woo, 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 woo. So the most important command we can do right now is copy running config startup config. All right, so this is what I'll actually do. So once we run this, we'll do the show run again. Now, once we do this, there should be an actual startup configuration when we run the show run command. Okay, so let's press enter. Enter. We've got the little confirmation. Now let's run the show. So there's this show startup configuration. Now it's established that it has an actual startup configuration, and it should be the exact same thing we set it to. There's our DHCP, there's our DHCP pool, our network, there's our username, SSH, IP domain name, there's our interface, there's our IP network that we've established, there's the SSH and the local login established. So what, again, we've taken that configuration file that was running in our RAM, and we've copied it over to where it needs to be in our NV RAM. All right, where NV RAM is where when it boots, that's going to be the configuration file that it uses. Okay. All right. So now that we've done all of that, let's exit now. Let's exit out of our router. All right. Oh wait, I gotta exit out of this totally because I'm in that. So let's go over to, now I have to just select. Now if I did everything right, when I select DHCP, this PC should now get an actual address. So it's established. So the DHCP server that's running on the router right now has now dynamically addressed this PC with the default gateway of 192.168.0.1. All right, very good. All right, let's go to our interface. Now PC1, we'll write this down. All right, this is PC3, so what's PC3? PC3 has the IP address of 192.168.0.101. Now remember, I said that was going to be the first address that it was going to hand out. That's because we excluded the 192.168.0.0 from 192.168.0.100. We excluded all of those addresses out of that DHCP server's range. So it's going to start at 101. And PC3 is evidence that it started at 101. Very good. Okay. Now we have that established. All right, now let's go to our desktop. Now, let's just make sure we have correct connectivity. Let's ping our router real quick. All right, so now we're getting those ICMP messages and replies back. All right, now let's SSH into that router. SSH -L. All right, Cisco and 192.168.0.1, and that's Cisco. Boom. So we've established SSH now. Now let's move into enable mode from SSH. So enable, it's going to prompt us for that password, that enable password that we created, and we've already moved down to enable. So now let's move into configuration. All right, I'm not going to do the shortcut commands anymore for you guys because I want you guys to see the full commands. And there we go. So we've established SSH. All right, now what I'll do is I'll exit out of this and we'll try to connect via telnet now, okay, too. So we've established SSH. We've gone through all that configuration with the user password combination. I know DHCP, we haven't talked about DHCP, but I always establish DHCP in my networks just because it makes it so much easier than statically addressing everything and adding default gateways to everything statically, because you tend to make mistakes when you do all that. So I've always found it best practice just to establish DHCP right away. And it also is just good practice too, because in the real world, you're going to be, at least from from what I know so far, you're going to be utilizing your DHCP servers and whatnot. So that's neither here or there. Let's continue on. So let's exit, and then we'll see if we can access this router via telnet. All right, so we're back on the PC here. Okay, and this IP config, that is the Windows way of seeing and I'm just showing you guys we're back on the PC, so you guys know. So it's showing the IPv4 address right there. It's actually, yeah, so there's it's showing you the gateway. Highlight some stuff real quick for you guys so you guys can see what I'm talking about. So IPv4 IPv address 192.168.0.101. Our subnet mask 255.255.0. Default gateway 192.168.0.1. Very good. Everything is going very well. Get rid of that real quick. All right. Now let's try to telnet. Telnet to 192.168.0.1. All right, it's trying. It won't open. All right, closed by foreign host. So we've established in the router that we don't want anybody trying to connect to you via telnet. Okay, so there we go. All right. So from here, that completes that part. All right. We can exit out of there now. And now we need to go into our switchy switch. So now that we have that, now let me just do this real quick. Let's start getting everything to have some addresses on it. DHCP, yep. And we're going to start getting addresses on all of our other devices. And while we're doing that, I'm just going to write down these addresses real quick. And then we'll continue on. So PC2 is going to be 192.168.0.102 now. Very good. Over here, this Larry Gary over here, we'll say DHCP. Give it a second, and then there's going to be its IP address. Very good. And then this is PC0, PC0. It is 192.168.0.103. All right, good. And Mr. One over here. Establish DHCP. And boom. So our DHCP server is working like a charm. It's already, we've already got established addresses throughout our network, and we should have network connectivity through everybody now. So let's go over to PC1, and we'll just do the IP config. We'll run that so you guys, so we can verify that 192.168.0.104 is our actual address. And we're going to ping PC3, which is 192.168.0.101. And there's our ICMP replies come back. Now let's SSH dash L, all right, into our router, which is Cisco at 192.168.0.1. All right. Give it our password, which is Cisco, and there we go. So we're all the way over here, which is separated by a bridge, and two other switches to our router, which is all the way over here. Now we're all in the same network, so we're not getting all crazy and fancy like that. But I just want to demonstrate that now, you know, we're completely remotely accessing this router via the network, okay? So we'll move into enable mode. So the enable, we'll give it the password, which is Cisco again, and then, you know, we'll move into configuration terminal mode. And then there you go. So we've established complete connection to our router, okay? Boom, boom, exit, and then there we go. Okay. Now let's get into our switches now. Now what I will do, get a little bit more water, is we need to establish a VLAN, okay, on our switch that's going to be our management VLAN. All right, and for where we're going to be, and for what we're going to be doing, we're just going to be establishing VLAN 1 as our management VLAN. And when we establish that as our management VLAN, we're going to have an IP address set on that management VLAN so we can access it remotely. So the only way we can access these switches if it has an IP address. Because right now, these switches are just you know, they're just relying all of that. There's no way for us to connect to it remotely. There's only a way for us to connect to it via console. So, since the only way we connect to these switches via console is we grab another console cable, we'll connect it to this PC. So PC2, we're going to connect over here to this switch right here. So we've made a console connection. Okay. Now let's access PC2. Let's go into the desktop. We'll run the terminal 9600, 8 and 1. Okay. We're going to say okay. And now we're in our switch. Okay. Now we'll run through those configurations. Again, we have to move into enable mode. Okay. Now remember, by default, there's no security on these switches. That's why we were able, once we hooked up that console cable, we can access everything right away. All right. Because by default, again, nothing has been created yet. Okay. All right. So now configuration, terminal mode. All right. All right. So we're back here, and we're gonna set SSH up again on this switch. So we're gonna run through that same thing again. We're gonna call this. We're gonna call you S1 though. S1. Okay, that's gonna be its host name. All right. Next thing, domain. Domain name, and we're gonna give it the same domain, which is we're just gonna say keep it the same, lab.com. Very good. And then we're gonna say crypto. I can spell tonight. Crypto key generate RSA. Okay, 1024. Okay, very good. We're gonna come over here now. We're gonna go into line BTYs 0 through 15. All right, we're gonna say login, local, transport, import, SSH, exit. We're gonna give it the username now. Cisco. Password Cisco. All right. And enable secret Cisco. All right, so we just established SSH now. Now we have to go now. Now that we have SSH configured, now we can access. Now there's one more thing we need to do before we can access this remotely now. Okay. Now that is moving into interface VLAN 1. Okay. Now you can assign your management VLAN as whatever you want to assign it to. Okay. But for this, we're going to assign it to VLAN 1. Okay. We're going to do IP address DHCP. All right. And what it's going to do from here, once we give it the no shut command, that VLAN, it's going to bring up, remember, this is a virtual, it's the switch virtual interface. That's what a VLAN is. It's a virtual local area network. So you have to imagine a switch is all the ports are inside of its own, as long as everything's assigned, and by default, everything's already assigned to VLAN 1. So by default, all your interfaces, all your ports are in VLAN 1, and conceptually, that's its own local area network, okay? And then that's where you can break. So once we get into more complex VLAN configurations, that's where you start creating separate local area LANs. If you can think about that, their own subnets off of your own VLANs and stuff like that. So right now, all the interfaces are all on one local area network, one VLAN, VLAN 1. So as you can see, once we established that our IP addressing for our VLAN 1, all right, our DHCP server, I've said, okay, so here's your address, my good friend, 192.168.0.105 at 255.255.255.0. So now we have an established IP address for our VLAN. Now we can access this switch remotely now, okay? All right, so we've done that, and yeah, we should give this a description. We're gonna say management VLAN. Okay, let's exit. Now again, what is the most important command that we need to do before we completely exit out of any command line interface on our network devices? All right, the most important command is the copy running config startup config. That is the most important command, because everything we just did will be gone. If, say, this router rebooted by any chance, we don't want to lose all that. So let's go back to enable mode, and we'll run that full command. So copy running config startup config. Okay, very good. So now that we've done that, let's get back out of here. Oh, we're still in the so I just have to exit out of here now, and we're going to come back to the command. So this is on the PC now, and I'll run the IP config. So we're back on the PC. We're not in the switch. Okay, let's SSH-L Cisco 192.168.0.105. Cisco. And look at, we're back into our switch via SSH. Okay, we're gonna go enable. We'll give it the secret password that we established, and now we're in enable mode. Okay. So configure terminal mode, and now we have free access to now remotely configure our switch. Okay. So let's write down our information that we have established for our switch. Okay. So S1 is on VLAN 1, and that is 192.168.0.105. Okay. And it has all the same passwords as I've established up there, so I don't need to rewrite any of that again. All right. And let's tab out, exit, say end. All right, exit. All right, so we've just closed out that. We've closed out that terminal now. Now we can exit out of there. Now I can go ahead, and what I'm going to do is I'm going to remove this console cable now from there. All right, and then I'm going to reestablish another console from PC2 to now this switch over here. Because remember, we cannot access this switch now either until we establish a couple things. The first thing we got to do, the first thing we're going to do is we're going to establish SSH. Okay, back on this switch. Then we're going to establish the management VLAN, which is going to be VLAN 1 again on this switch, but we're going to enable DHCP. It's going to get its own address, and then again, we should be able to, from any PC within this network, the network admin should be able to remotely access any single one of these command line interfaces on these network devices. Okay. All right. Go back over to here. Go to the terminal. 9600. Now we're on the switch. It's a brand new switch now. Okay. Let's go to enable mode, configuration, terminal mode. All right. Host name. We're gonna name you S2, SW2. You love it. You know it. You want some more of it. IP, domain, name. All right. We're gonna do the same thing. Lab.com. All right. And we're gonna create the crypto key generate RSA 1024, very good. IP version. That command does not exist on that, does it? Okay, that's fine. Doesn't have to be. That's fine. Not the end of the world for me. All right. Let's go into the line configuration mode, VTY line 0 to 15. We're going to say login, local, say transport, import, SSH. All right, exit. We're going to create the username, Cisco, pass Cisco. Enable secret now. Cisco. All right, that's done now. Now let's move into interface. VLAN 1. IP address DHCP. Shut. All right, it's going to get an IP address now. 192.168.0.106. Very good. All right, well, give it a description real quick. We're going to say VLAN. Good. Exit. And exit. Copy. Running. So we've established SSH. We've created the IP ad. We've established the management VLAN, VLAN 1, and we've given an IP address with the default gateway and all that happy stuff. So from here, we can exit out of there, go back to our terminal on our thing, and we can SSH. L to Cisco. Cisco, right? 192.168.0 dot, what was that? 106? Yeah. Password Cisco. Enable mode. All right, so now we're back in S2. So let's write S2's information down here. So SW2 is at VLAN 192.168.0.106. Right. Cool. All right. And we can delete that now. Now, from here, again, we should be able to attack. Well, not attack, I don't want to say it like that. SSH-L, Cisco, and we're going to say 192.168.0.106. Password Cisco. Enable. Cisco. There we go. So we've gone over SSH. We've covered SSH a couple times now, okay? And we should also, so I'll end this again. No, man. I love the fact that Packet Tracer even thinks that it wants to do this. The guys who made Packet Tracer, they must have built in a timer to this one to emulate that mistake. All right, come on, hurry up. Oh, wait for you. Come on. Yes, I know. The domain server is not going to find it. All right, enough of that. All right, now let's try to telnet. We'll try to telnet into one of those devices. 0.106. Oh, look at that. It says no telnet for you. All right, very good. Cool. So, I guess what haven't we covered yet? So we've covered chapter 6 pretty well. Chapter 6 pretty well. Remember, chapter 6 was configuring basic switch management. Let me go back to chapter 1. Chapter 1 is, that's just the introduction to TCP. We've covered chapter 2 in the beginning by when we, instead of using the auto connect, we went with the actual rail wires that we need to use between these devices. So remember, when we connect a router to a switch, we use the copper straight through, okay? But when we connect a switch to a switch, we use crossover. A switch to a bridge, we use crossover. A switch to a PC, straight through. All right, bridge to a PC, straight through. Okay, so that covers chapter 2. All right, so we lab chapter 2. All right. Chapter 3, fundamentals of WANs and IP routing. So to kind of cover, I guess, let's do this then. So what we can do, let's grab that, grab another PC, put you over here, let's establish a connection. Is there a WAN connection? Coaxial phone, fiber. I want to establish. I'm representation number, wide area. Whatever. What interface is that real quick? So that's var 0. Give this the IP address. IP address 92.8. And 2.100. Yeah, that's fine. This is just purposes, guys. Got okay. The rest base 0.0.0. Say 2.168.2.1 0. Got okay. Get DHCP pool unit work 2.168.2.0 0 default 2.168.2.1 2.1 exit IP TCP exclude 192.168.2.0 good. And that should get that. I'm just setting this up so you guys can so we can cover like encapsulation when we start getting packets and stuff like that. Bigger DHCP. Should get an address now. So PC4 is 192.168.2.1. Oh, I gotta establish. F1. Area 0. Yeah. All right. Oh, just 0. 2, 5, 5. F. Work. Good. Do show routes. Do show. Doesn't like that. Come on, OSPF. Come up. Some OSPF neighborship. All right, so it's gonna give me a hard time. That's fine. Well, there's more. There's a couple ways to skin this cat. This is where 1, 2, 0. That's it. Oh. There it goes. Now it made its OSPF neighborship. That's all I wanted it to do. See this right here, guys? So I know we haven't got that far yet, but I needed it to establish a neighborship, because what it's going to do, it's going to enable us to route between these two networks here. To show. So, there we go. So what we did is see where it says this O right here. We've established a OSPF neighborship with that other network. Okay. All right. So now we come over here, run that same thing, and there we go. So now we can ping that other network. So I just had to establish OSPF real quick on the routers and create a neighborship real fast. All right. So now that we have that established, what we can do now is we can come over to here to simulate mode, and what we can do is I'm going to edit these filters. What do I want to see? I don't want to see that. I don't care about any of this. So ICMP. So I just want to see ICMP. Okay. I don't care about DNS. Don't care about BGP, EGRP, OSPF, DHCP, HRSRP, and RIP. And we'll show RIP and ARP. Yeah, we don't need RIP. All right, so we'll just show ARP and I don't need this. I don't need any of these. Oh, PPP, yep. So that. TCP, UDP, yep. S3s. Not get into any of these these are a lot of like the application messages that you can see through. CDP, PPP, yep, I'll just keep PPP. TCP and UDP messages, yeah, okay. Oh, okay. That's the only ones I want to see. That way it doesn't get too crazy when I start to do this. All right. This. Do that again, and we'll start. We'll play it, and we'll see the packet on how it's going to. Oh, OSPF, open shortest path. What OSPF enables is it creates a neighborship. It creates a neighborship to another network. So when you're connecting over multiple networks, over subnets and whatnot, when you have a router between those, you need so BGRP, that's what's running the big internet. That's the protocol that runs the internet. OSPF, you'll find that in a lot of like enterprise networks and whatnot, wide area networks, campus networks and stuff like that. It's a protocol algorithm that enables this right here, router to router. Okay, we're separated by an actual different total network. So this is its own network. And again, I haven't gone that far yet. This is its own network, and everything over here is its entire network. So imagine as this is its own LAN, and this is its own LAN. This is the WAN in between. So this area right here, this is the wide area network in between these two local networks. So I have one network. This is my WAN. The only way to be able to get to route between those local area networks is you need a protocol, like OSPF, BGRP, EGRP, RIP. If you've ever heard of RIP was the old protocol that used to be used, but RIP is no longer used anymore. But that's what I had to enable. Get out of this. Let's go back to real-time mode. I had to enable, and I'll show you. Erase that real quick. And you see this message right here. OSPF adjacency. It's made our neighborship with the other router. So when I run the show IP route command, you'll see where you're seeing this O, and that's because it's connecting. It's pretty much learned that network is all on that other router's interface. So it's saying, okay, well, I know that if I send packets out of this network, that other network has a connected network, and that other connected network is that other network. So it's so that you got to get away from like switch logic. So switch will just blast out frames. Routers need to know where they need to route to. So how that happens is this protocol. So by you establishing a neighborship with another router, that router is going to then fill up. It's going to advertise its route table to that other router. So there's the terminology. It's pretty much saying, okay, these are my routes. Okay, now when you get a packet going to wherever network that you need to get to, well, these are the routes I have, and maybe I can get you to that IP address. And so that other router says, okay, let me take a look. Okay, well, I see that I just got this ICMP frame that I need to go to this network. Okay, cool. I see that network on your address on your table. Cool. Now I'm going to send it off to you, so then you can send it to where it needs to go. So that's what OSPF. So EIGRP, OSPF. Where's BGP? Where's BGP? BGP. Where are you, BGP? Why isn't it showing BGP? Oh, BGP. So BGP is what runs the it's what the big internet uses as its protocol. I believe so. Yeah, I believe so. But yeah, those are very important protocols that need to be established before you can route between multiple networks and whatnot. So that's what that. Great question, by the way. Thank you very much, Fuzzy. I love giving out explanations. All right, let me simulate this one more time. Go back. We're gonna look at some of those packets again. Ping that other network again. Drop you down. We'll press the play button. And what we're watching is this router. It's sending. Make this a little bit bigger. Yeah. It's sending its ICMP message. Okay. Off to what did I echo? PC3. So it's going to send that ICMP message to PC3. All right. PC3 is going to get that message. This is when the reply goes back. So now the reply goes back. It's going to go through the router. All right. What we're going to do is we'll take a look. We'll take a look at these. Oh, you're very, very welcome, Fuzzy, and thank you. Thank you very much. And what we're going to do here, I'll stop that, and let's look at when so we went from this is the first message, okay? And the first message here, it has the source at 192.168.201. That's our PC, okay? it has our destination, which is PC3. All right. Can I expand on this a little bit more? There's the source and destination again. Can't really expand this again just a little bit more. I want to see MAC addresses. So it's not giving us MAC addresses. So that's that one. So now here it comes into, it came from the PC. Now it hitting that router now. Okay. Okay. So now it's going to start showing us some MAC addresses. So here it is. So inbound source, we have our MAC. Okay. We have our IP address. Let me take that back. So there's our IP address again of PC4 to destination PC3 on the other network. Okay. Here's our layer 2 information right here. All right. Now, again, what's going to happen is when this router right here is going to get this message, all right, it's going to de-encapsulate and re-encapsulate this message, okay? So we'll go back, now we'll go to these two. So this is when this router got the message and sent it off to this router, okay? So this is coming from that other router, all right? And there it is. The source is that PC4 again to destination PC3, okay? But if you can tell already, the MAC addressing has changed now. The MAC addressing has changed, okay? All right. So the MAC address now is representing by this interface on this router, okay? And it's sending it off, okay? All right. Go to here, and this is when, so now it's not, so the router is now sending it to the switch, because the switch, obviously, it's going to be sending it down to the PC3. So since so switch logic only works at layer 2, so here's that packet, okay, at layer 2, all right, switch to the PC now. So there we go. Here's the source. It came from from PC4 to destination PC3. All right. Here's our MAC addressing again. Then all right. So now it's changed. All right. So the source now has turned into PC3. Destination is now PC4. Okay, because now we're going to be sending back our replies now. So there's that PC to switch now, and then switch to router. So here's our source. Source is now PC3. Destination is now PC2. Okay, so this is how the packets. This is how it looks when the packets are being sent through, and then the logic. So the source and IP, the source IP and destination IP are going to stay the same. The MAC address, as the MAC addressing is going to change as it's flowing through this network. Okay, the router is going to de-encapsulate and re-encapsulate that ICMP message as it goes through the wire here. Okay, so when it de-encapsulated at this point, it's going to pick up this interface's MAC address. It's going to blast it out of here. When this router gets in, de-encapsulate, it's going to pick up this interface's MAC address, and then it's going to send it to where the destination is. The switch logic already learned the MAC addressing of where PC3 is, so that's why that message didn't get flooded out that frame. But if this switch hadn't learned PC3's MAC address, it would have flooded that message throughout its interfaces, so it would be able to locate where the MAC address for PC3 was. But it already learned it, and that's why it sent it there. That's why when we looked at the router to switch and then the switch to PC3, it had the MAC address table on switch 2 over here has already been filled up via the MAC address table. All right, so that's a depiction of a WAN. All right, wide area network again. So this This right here is our wide area network. This is our local network. This right here is our local network, okay? Local network, wide area network, local network, okay, guys? Local, wide, local, all right? This would represent the internet right here, guys, okay? All right? Erase that. All right. So we covered, and that is covering chapter 2 and chapter 3. All right. And then what is chapter 4? How are you tonight, though, Fuzzy? Doing good? Chapter 4 is just command line interface. So that was just the establishment of the command line interface with the cables and connecting to the console. We've covered that. Ethernet, analyzing Ethernet LAN switching. We've covered that. We'll run a let's run a show Mac. All right. Oh. Show Mac. So here's our show Mac for for switch 2. All right. Just make this a little bit smaller. No, can't make it smaller. Oh, that's as small as you're gonna get. All right. So it's established. It's already got. It's already been dynamically filled up with addresses. So out of 501. So 501. Which one is 501? It's kind of hard to tell when everything's getting in the way now. It's gigabit 0-0. So gigabit 0-0 is going to this switch right here. 501 and 502. All right, so 502, so PC. So PC. So there's the MAC address. So that is 4995. Let's look at this. So 4995. So 4995 is out 502, and that's PC3. And then 9801. 9801 should be this guy right here. And where am I? Your Echo 32. So back over here. Echo 32. Doing 9801. So that's that one. This one. So it's connected to which? 1, 2, 3, 4, 1. Oh, okay. So it hasn't even learned this one's yet. Yeah, it hasn't even learned this one yet. We haven't sent a message out of this one yet. Be damned if we didn't. 192.168.2.10. So there we go. So that was great. Yay! I was able to show you that. So PC, that's what I was getting confused on. PC2 hadn't been learned yet. And that's why I was like scratching my head for a second. So PC2's MAC address wasn't dynamically known yet because PC2 hadn't sent out any information throughout its throughout the wire. So we only had 3, and I'm looking at the the amount of connections I have. 1, 2, 3, 4 connections. I'm like, where's 9801? And 9801 is the router's, this router's interface right there. But I didn't have PC, what is that? PC2. PC2 is out the FA03's interface on that switch, which is Echo 032. Cool. So that covers chapter 5, pretty much. We went over SSH, and we covered configuring, verifying switch interfaces for the half duplex, and so we have our bridge right here, and because of how a bridge logic is, what this switch, because of auto negotiate, we'll do this. Well, let's do a show run. This is that going out of FA02s. So we need to do a little bit more deeper analysis. So show interface FA02. So FA02. All right, there we go. Beautiful. So FA02 is running still at full duplex. Where'd it go? But it dropped it down. It dropped that fast Ethernet down to 10 megabytes per second because it's connected to this bridge here. Now, what's connect a hub? Let's grab a hub, and a hub's gonna make it drop. It's gonna put it into a hub will put this into half duplex. All right, so we are connected to the FA03. Once that comes up, is it in the up? I think it came up. Yeah, it came up. So let's do a show interface on the FA03 interface now, and so because of auto negotiate, the switch has, because it realizes the hub, and the hub only works at half duplex, so it switched. So auto negotiate switched that interface to half duplex, but it kept the speed at 100 megabytes per second. So just like at the switch connected to this bridge, it keeps it at full duplex, but it drops the speed down to 10 megabytes per second. So that covers auto negotiate and how auto negotiate on a switch, how that logic stands and how that works. So that covers that. And yeah, that's it's a pretty tight view of what we've gone over for part 1 and part 2. Any questions out there that pertain to part 1 and part 2? Fuzzy, you have anything for me? How many people I got on my, what do we got on? I got 3 people on YouTube. Let me just check YouTube chat real quick. I just want to make sure that my peeps over at YouTube, if they got anything for me. My peoples over in YouTube, do you guys have anything in chat for me? Any questions at all? I know there's about 3 people watching me in the YouTube. This would be the time, if you guys have any questions out there for me, to definitely hit me up in the chat. And I apologize if you have been chatting. I still am working on a way to monitor all 3 chats all at the same time. So that's a work in progress that I have to do for me. But no, yeah, I don't see anybody chatting it up. So my folks over at YouTube, I'll be right back, I promise. And my Twitchers, if you guys have anything for me, in chat. Again, this would be the time to chat me up. Let me reload that real quick because now it's lagging. There it goes. All right. All right. So, all right. So we've covered that. So what I'm going to do now is I'm just going to pretty much talk about what part 3 is going to be. And part 3 is going to be chapter 8, chapter 9, and chapter 10. Chapter 8 is going to be implementing Ethernet virtual LAN, so we're going to be taking a deeper dive into VLANs. Chapter 9 is spanning tree protocol. Spanning tree protocol is a pretty neat one, guys. That's a fun one. I've almost exploded my computer before with creating a broadcast rule. I did that in Cisco Modern Lab. This time we'll do it in Cisco Packet Tracer so I don't break my computer. And then chapter 10 is RSTP, which is the rapid spanning tree protocol, and Ethernet channel configurations, okay? So chapter 8, we're going to be looking at VLAN concepts and layer. We're going to be using some layer L3, some L3 switches here. We're going to be breaking them up. Yep, so that's what this is going to be covering. So we're going to be breaking up a switch into multiple VLANs, and then we're going to be establishing trunks, inter VLAN communication. I'll show you guys the router on the stick, network topology. That's a cool topology to set up, guys. And that's a good one to practice too. The network on the stick topology. It's a good one to practice trunking, multiple VLANs, and then how to route between those VLANs with using a router in it or using an L3 switch. So that's a fun one. That's a really cool one, guys. Because trunking can get a little confusing. It had me stumped for a long time. It took me a while to get over how to manage trunks and whatnot. Next, and then chapter 9, that's STP, spanning tree protocol. Spanning tree protocol is what prevents a loop, a broadcast storm, when you add redundant links within your network. Okay. So when you say like the spine leaf type topology, with all those redundant links that you'll create, if you didn't have spanning tree protocol working within those switches, you would create an endless loop that would it would make that topology useless. It would make that network useless. It wouldn't be able to work at all after that. And then we're going to get into RSTP, which is rapid spanning tree protocol, which is the newer version to spanning tree protocol. And then Ethernet channel configurations. Ethernet channel, that's what it starts getting on to like load balancing, and redundant links and stuff like that. That's one that these are the next couple chapters that we're gonna start getting into the weeds of everything. So that's part 3. We'll be picking up part 3 then, guys. Join me Monday. So Monday, what's Monday? Monday the 14th. Same time, 5 o'clock Eastern Standard Time. I'll be streaming again live on Twitch, live on YouTube. You guys, this has been a great experience, and I truly honored you guys as giving me you guys' time. You guys are awesome. I love every single one of you. So yeah, come join me Monday, 5 o'clock sharp Eastern Standard Time. Okay, so figure that out, and if whatever time zone you guys are in. All right. Over this weekend, I'll probably be streaming over this weekend. I haven't set up an established schedule for my streams over the weekend, just because I do that's my time to like hang out with my kiddos and whatnot, and we tend to play a lot of video games over the weekend. So over the weekend, I'll probably be streaming. I'll be doing some gaming and stuff like that, just because it's fun to do that with them. I love gaming too, guys. So if you guys like watching video game streams and stuff like that, make sure you guys follow me or subscribe to me on YouTube. Follow me on Twitch. That way you guys get the notifications when I'm up and streaming. And yeah, guys, I hope to see you guys live on the next time. So, mwah! Till next time, guys. I love every single one of you. You guys stay safe out there and have a good night. Have a good night, everybody. It's time to go.